everybody. I'm Gary Macker on Ocean State Signal. Welcome to part 4 of the Siemens Pro M60 programming series. We've done pretty good to this far. Hold on a second. I had to turn down the phone. We've covered a lot of material this far. Today we're going to be going over, basically this is probably going to be the last of the series, the last part of the series. We're going to be covering preemption priority, a little bit of some system. I'll go over some of the reports and the active status screens. So it'll be mostly all controller, a little bit of the board work. So we'll get right into it. First, I just want to cover a couple of things from last week. Just had some questions during the week. One thing, if you remember, last week we did coordination and time base. And if you remember my coordination plan, if I go back into it, if you remember on this screen, my cycle length was always 100, and then I made a couple of changes that went to 115. I was trying to figure out what the heck went on. When I went into the ring structure, what happened was I had taken, see, I don't have any co-phases right here. I had taken those out. And what that did was basically, just to give you an idea, let me put it back in right now. Except this is going to restart. Going back, oh, I left my little pointer in the, where's my pointer? I took my pointer home and it's probably in my room, my orange pointer. Basically what happened was, so if I left this up on the board, it was from last week. So this was 100 seconds, if you remember. So 15, 25, 25, 25, 25 is 50, 15 and 50 is 30, plus 50 is 80, and 20 gave me my 100 seconds. Okay. Gary? Oh, all right, sorry about that. Anyway, so what happened was I added 15 seconds. It was coming up with 115 seconds. So this was 100 seconds. And then when I took phase 1 and made it non-compatible, it basically was adding this 15 seconds in, and I was coming up with 115 seconds. So I was just trying to demonstrate something. I forget what it was in the ring structure. And when I put it back in, I forgot to put it back in. So it was adding 15 seconds. So basically it was adding a 15 seconds, and that's why I couldn't find what the heck was going on. It took me like 5 minutes to figure out when we got done yesterday. But anyway, that, and so we're doing so again, going back into our ring structure, when we do this, this is again why I say we leave everything in the ring structure that we can, even if we're not using it, and then we just turn it off in the initialization part of it. Okay. Okay, let's get started with what we're doing today. So we're doing preemption. So let me go to my whiteboard. Go back. So a couple of things about preemption, okay? So preemption basically is when we have to preempt the signal for any one of these reasons that I have listed up here that I'm going to go through. So in the older controllers, we basically had preemption, and then there was a priority screen inside of that. All right. In 3.5.8D and going forward, priority has become such a popular thing that we've expanded the functionality of priority. So we actually gave it its own little section in the controller because we wanted to get a lot more programming in there. Okay. So basically, if we just break down the two of them, preemption, and there's different, a hierarchy to preemption. A lot of people don't really realize this, but the number one would be bridges. So they're on the top of the mountain. They're the king of the hill. We don't have, drawbridges around here would take precedent over any of these other ones. So we have bridges, then we have railroad, and then we have what we're all typically used to, which is EMS, which is fire and rescue. And a preemption basically is an instant transition from normal operation of the sequence to a rail crossing, to a rescue, to fire, if there's a drawbridge opening, because we need to have this happen instantaneously. So it interrupts on normal operation, and we go and service the preemption event, which I'm going to get into the program of. And basically we have they used to have preemption, and we used to have high priority and low priority. And basically this would be all our high priority, and these things down here would be our low priority. But we've basically just broken them out in the controller. You still have them on the devices, on your preemption cards, high priority, low priority, but in the controller, we break them into two different sections. Your priority basically is going to be, there's not really a hierarchy, I just kind of put this together, but it would be TSP, which is a transit signal priority, which would be your buses and your light rail. So light rail is different from trains. Trains are your Amtrak, your Acela trains. When I mention light rail, I'm talking about the T, like on Beacon Street and Brookline, you know, in Watertown. That is considered like a light rail, like a shuttle train that kind of stays inside of the city. Okay. And then in some places, DPW vehicles. So plows could have emitters on it to do low priority. So basically they don't have to stop at the traffic signals, and I'll get into how that priority benefits them. Same thing I've seen, sanders, street sweepers, like I said, mostly DPW vehicles will have these. And then lastly, one thing that you'll see in a little more common is funeral vehicles. Probably one of the most dangerous things that I see on the roadway is a funeral procession. You have a lot of senior citizen drivers, you have a lot of younger drivers, and people just aren't in a great state of mind. They're traumatized, they're upset with the death of a loved one. So driving down the road isn't usually, their main focus. And you have a lot of out-of-town people. So you have people that don't know where they're going. So if it's somebody that's popular and you have 20 or 30 cars in a funeral procession, people are trying to stay bumper to bumper, and then what happens? Everybody gets to run a red light. So now you get people not paying attention. Why is everybody running the red light on? Why is everybody running the red? So to preempt funeral processions, to me, I think is a great idea, because you give them the green, basically like a fire vehicle. It doesn't happen that often, but it would be safety, and we're starting to see a little of that, okay? So that's kind of the difference between a preemption and a priority. So a preemption and the priority, I apologize, is a delayed transition. So through the program that we'll set up through priority, we end up giving these vehicles the green signal or the right of way, but it doesn't happen instantaneously. It's a slow transition to get to the priority, because we just want to prioritize them generally to get through the intersection so they don't have to stop. But it's not an emergency. Buses and plows and funerals are not emergencies. We're just trying to give them a right of way, get them through so they don't affect the normal queue of traffic and normal operation. So preemptions are typically emergency situations. Drawbridges go up, trains are crossing, emergency vehicles. We got to get them right through. It stops everything. And then priority is something of just prioritizing over the other vehicles that are in the intersection, the regular everyday motorists. Okay, so that's the difference between the two. You're going to hear a lot more of it, especially TSP, transit signal priority. That's becoming very popular. We're doing a lot of work with different bus organizations that are trying to take advantage of this. The main reason we did a big project for RIPTA, Rhode Island Public Transit Authority, about 5 years ago. It was 75 intersections, and basically they called, it was defined as the R line. That's what they designated on. So all the buses say the R line on it. So a bus line, this was called the R line. And after we deployed all the equipment and got it running, and we did fine tuning of timing, they actually were able to eliminate one of the buses on the route because the scheduling was so much better. So instead of buses being continually late, so they're late all the time, they add another bus to try to make up for the lateness. Everything was on schedule or ahead of schedule. They became much more efficient. ridership went up, they actually were able to get rid of one of the buses. So it was a big cost saving for RIPTA. They got back the investment. So their return on investment was great. And now they're in phase 2 where they're extending it around the state. So we work with, you know, the bus companies in and around Boston, the middle of the state, out in Western Mass. So there's a lot going on with the signal priority, and it's not super hard to do. There's a couple of different manufacturers that do it, and I'll get into the priority on how that works. Okay, so right now we're going to jump into preemption because that's generally what everybody's most familiar with. Everything looks right on here, Wayne?
See.
Okay. Do me a favor right now, type in a question, because some folks said that they weren't able to ask questions last week. I don't know what was going on with the type in a question thing, if it was them or if it was us.
So Jim asked a question, if you use PEDs to control coordination when the preemption is activated, does the PED have to go through walk time before the preemption is serviced?
I'm going to get into the PED. So the question was essentially, let me look on the board. If you use the PED to control coordination, on the preemption is inactivated. There you go. Does the PED have to go through the normal time for the preemption? Okay, so the question was basically how does the controller treat pedestrians when we're in either the walk or the clearance portion of the walk? How does that work with preemption? Basically, I'll go through that right now in the program to answer that question on how we handle PEDs through timing. So I'll go to 7 for preempt. So you'll see right now on the screen, standard, we always had 6 preemptions. We always had 6 high priority preemptions, 6 low priority preemptions. If I go back one screen, you'll notice option 7 is preemption data, option 8 is priority data. So that's where we've kind of broken it out into 2 separate things right now. If you look on the preemption, we actually have 12 preemption events that we can do now. So our standard 6 that we've always had, and then they've added an additional 6. And I'll show you how we can get to those additional 6 through program and what you would need to do to get those to activate. So basically, the one biggest thing everybody's liked is we've actually lined it up now. So when you go through the keypad, preamp 1 is actually number 1. It was always for eternity, legacy eternity that we were always offset by 1. So preamp 1 was key 2. Preamp 2 was key 3. We never lined it up because we had 1 was our miscellaneous. Now we've added miscellaneous into all of them, so everything lines up 1 to 1. Doesn't sound like a big deal, but it's given a lot of people a lot of aggravation for a long time. So little simple fixes make everybody's life easier. So here we go. So we're in preamp 1. Breaks down into the 5 screen. So here's our miscellaneous now. So here's where we start to do our program. And so this question actually came up twice this week. You'll notice where the green cursor is. You'll see where it says detect or detector, the preempt detector, and there's a number there, 248. If you look down below, because I hit my help button, if you look down below, you'll see where it says 248-253, PE1 to PE6 inputs. So the preemptions have all programmable inputs right now, where before preempt 1 through 6 was always inputs 248 to 253. It was always like that. The only difference now is they're programmable, so we can program to anything we want. And so we just have the luxury of programming. And this just ties again into TS2 and what we're able to do with TS2. I had a couple of people call me this week for the same problem. If you ever go out to check preemption and you see that you look on your processor card, you put a preempting call, you see the yellow light come on the card, the preamp is active, but nothing's happening in the controller. Your problem is probably, enter. You could have a 0 value in your detector screen.
Question.
Yes.
Is it possible to program, support me, coordination to these controllers?
No.
And we don't.
So what I'm saying right now is, so if you look at the detector, if you look at 0, it says unassigned. So if I don't assign an input to this detector, it's not going to work. So basically, you're going to get the preempt call through the processor, but the controller is going to ignore it because it doesn't have an input to assign it to. So that was the problem that they have. And if I default the controller, it will automatically default. Oops. 248. Okay. If you look down where it says assign PED detectors 1 through 8, I can make it 73 if I wanted to. Then we'd have to tie the PED detector routine to PED detector 3. So it's something most times you probably won't use, but it's there if we ever need it, okay? So the only time that I generally see these end up as 0 is typically if somebody does some type of upload or download with tactics and they had a problem, maybe there was a controller revision problem or something like that, where it just accidentally dumped a 0 in there. So you want to make sure that that always has the value in there of 248, and then I'll go, and then it just preempt 2, you'll see it's 249, 3 is 250, and something like that, okay? And then we'll just kind of go through, delay basically is what it is. We can delay the preempt call. We would use this when we do preemptions outside of firehouses. So not at the fire station, if we're preempting with a push button to get out of the fire station, and then there's a signal to the right or the left that we want to preempt, we'll put the call on, but we'll delay that call. So they'll hit the push button in the fire station. Typically, we could have a 30-second delay. Well, we wouldn't delay, it would activate for about 30 seconds, but we would delay the call into the second intersection. So we don't want to lock up that intersection for a minute and a half. When the truck pulls out to take a right or a left, then that intersection can go green. So basically we're just delaying the call. Just like we delay a loop detector call on right turns, we can delay the call typically for that reason with firehouses. Max call, basically this is the call time can remain active. So typically we do 2 minutes, 120 seconds, and then it'll shut off after that. We don't want it to go, for infinity. If an emergency vehicle pulls up and leaves the emitter on, we don't want it to lock up the intersection for 30 minutes or something like that. So we put a max call time in there. Input debounce time. This is more, we've used it in places for not troubleshooting, but basically, I remember we did a job where we were getting a lot of reflection off of signs. So basically, the call was kind of shuttering and putting in a call to an opposite phase because it was getting a reflection. So I can kind of put in this as like a debounce. So basically, it helps lock in the call so you don't get false calls. It's something I use just very, very unique situations. Something new they added, so preempt test call. If I ever want to just test my preemption, I can just put a 1 in here. It was kind of like a recall. I can put a 1 in, it puts the recall on for 1 time. I can put a 1 in here if I don't have a push button, but I mean, I can do the test push button in the cabinet. If I don't have that, I can do this, or I can just do it through the front of the card. But here's just another way to do it through the controller. Going through non-lock, basically same thing as a detector. You have locking memory or non-locking memory. You want to make that call. Sometimes we want to lock that call in, so we would make it locking memory, and then other times we treat it like a presence call, so we put it in non-lock. Extending the call, same as delaying it. We want to delay when the call goes in. We want to extend the input after the emitter, the detector sees the emitter. Commonly we use this when you're coming to an approach, and we may have an advanced detector where you're coming around a corner, going up and down a hill. So you may, instead of dropping the call in between where the fire vehicle sees the first emitter, which could be 1,000 feet away, so it could pick it up, but then because the curvature of the road, it may not see the other detector for 300 feet. So if we extend the call of the first one, it'll lock in the second one before, so we don't get any interruption in the call, because we don't want to drop out of the preempt before we actually activate it in the intersection. So that's typically when we do that. Basically, lockout, this is how long we're going to lock out a preempt after we service it. We typically leave these at 0 because if another emergency vehicle comes in, we'll go back-to-back preempts. Selective return mode, this is just a way to enter and exit preempts. Pretty much full auto is the default. That's what we use all the time. Linking a preempt, basically we'll do this for a priority. So a lot of times when we do the bus priorities, we'll link them to a preempt, because our preempts we can control the hierarchy of a preempt. So our preempts go 1 through 12, but I can make 4 higher than 1 based on programming. So if I link a priority, so this is the way I make the hierarchy of a priority. I link it to a certain preempt. Preempt duration and time. This is basically for the transition back to normal operation. Again, these are generally all set to 0. Gate extension time. Preemptions are used with, we sell a gate, some usually use these, the gate opener system. Typically emergency vehicles need access to a facility like a school, corporate grounds, private grounds. So they have their one-way road in, and there'll be a preemption detector over there. The emitter will get it. It'll open up the gate and it'll allow them access. So that's basically the extension time beyond what the call is. Again, something we don't generally use. Return to coordination. If we're going back into coordination, this is something that we don't use. I'm going to play around with a little bit, because there's always an issue when you're in coordination, like we talked about, and you have a preemption event. It throws us out of step. So we go out of the coordination, and it generally takes 1 to 2 cycles to get back into coordination. So I might play around with this a little just to see if it might be a smoother transition back in. Honestly, I don't think I've ever used it, and it's a new feature. If I find that it has some value to it, I'll introduce that to folks when we're running coordinated arterials. And then when we do preempts, we have to exit. When we come out of the preemption routine, we can control what phase that we go to. So I left some of the stuff on here just in case we had questions. So if I have a 1 and 6 Main Street preemption, because typically these come up together, 1 and 6. Typically when I return, a lot of times the design plans will say return to 2 and 6. So if I just preempted 1 and 6, let's say the preemption event took 30 or 40 seconds, that means the both side streets, everybody had an all red for, let's say, 45 seconds. When I return, I drop phase 1 and I go right into 2 and 6. So if 2 and 6 has 50 seconds of time, I now get 45 seconds plus 50 seconds. I've been almost 2 minutes on the main line without going to the side street. So what we're seeing more through design plans, and we like to make this recommendation, is if you have a preempt on 1 and 6 or 2 and 5, why not return to 4 and 8? Why not return to the side street so we don't queue up these big queues of traffic? Unless they're lightly traveled side streets, it's not a big deal. But if you have some demand, it doesn't hurt to return back over there. So you can control where you return to after a preempt event. And then the same thing with vehicle calls. I can place calls wherever I want. Typically, we put them on the main streets. Your main phases, which would be 2, 4, 6, and 8. Some people want it. Some designs call for putting them on all phases. So we have the flexibility based on the vehicle demand of that intersection, how we transition back in. Okay. So that's the miscellaneous. You have to put information in there to get this to work. Not that hard. Now, interval times. All right. This is where this kind of goes to the question regarding the PED question. So this is kind of broken into a couple of different sections, this one screen. So interval time. So min green min green, min walk, dwell green. So min green and min walk, basically, these are default timings that get put in there. Is in preemption, they'll always default timings for values like min greens, min walks, and dwell greens, which is kind of your max green. That because if the values are not in your regular phase timing, min green, yellow, red, it can default to these. So depending on what those timings are, sometimes it'll time this, sometimes it'll time that. It'll basically time the safest time. But we want to have minimums in there. So typically we'll make the min green, we'll typically make it 5, the min walk is 5. The dwell green is how long that stays on there. By default in the processor is 6 seconds. We do 10 seconds, so it times the 10 seconds. So when it gets from the time it drops the preamp call, it times it for 10 seconds, and then it starts its routine to exit the preemption phase. So that's standard what we do. In the extend ped, we generally leave that at 0. Go down. So you'll notice this is broken into 3 sections: select, track, and return. So select is how we transition into the preemption and how we get out of certain phases. So the question that came in about ped clearance. So the common rule of thumb is we can preempt out of a walk, right? It's okay to preempt out of a walk, and we can manipulate that walk time because the walk time is just the time that allows people to get off the curb to stop walking. We really are not supposed to preempt or truncate the ped clearance time because that's that's a formulated safe distance from curb to curb on a roadway. So the default rate here is 8 seconds. So at 3.5 feet per second, that basically is saying roughly 8 times 3. It's like a 25-foot wide roadway with 8 seconds of ped clearance. If I was to make that, if I preempted to 1 and 6, and I was in the walk phase, because I have 8 seconds in there, it's gonna time that 8 seconds of ped clearance. I'm not truncating that. Because if there's somebody in the intersection, they have to have enough time to safely get across so they don't get hit by a fire truck. That's why when fire departments, they have training classes on how to drive with preemption, that's basically giving them a right of way. But if they, we have the confirmation beacon in some states that goes off in the middle of the intersection. That's telling them that they've received the preempt call and they should be getting a green. But if they don't have a green, more than likely that means they're probably going to walk somewhere because we've dumped out of all the other phases rather quickly. So even though they train the drivers to say, you're going to get a green right away at some point, you still have to look for pedestrians and vehicles that aren't paying attention. So to go back to the question that was asked, what happens to the PEDs during coordination? It doesn't matter if we're in coordination or free. It doesn't matter. We're still gonna time that PED clearance time before we dump out into the coordination. So what we do, if I have a 20-second PED clearance, then I typically make that PED clearance 20 seconds. We will typically match up to whatever the PED clearance is on the plans because that's the safest way to have the intersection operate. If a design consultant or somebody else wants to truncate that and lessen it, that's on somebody else. We just match it up to whatever the PED clearance is on the plans. That's what we get that time for. And then you have the yellow and the red, which is standard at 4 and 2. So it's usually basically close to whatever your normal phase timing yellow and reds are. So that's how we go in. That's how we transition in. We select, we transition into the preempt. So the middle part, this is track, what they refer to as track clearance. Track refers to railroad. So when a train is coming, so the train hits a track switch, depending on how fast it's going and how much track there is, it'll hit a track switch you know, 1, 2, 5, 600, 1,000 feet away, a quarter mile, you know, half mile down the track. And what that does is it starts a preemption routine in the controller. So we'll do something called a track clearance. So we don't want to go right to an all red because there may be vehicles crossing over the track. So basically we'll have a track green time, and that's basically a track clearance. So any vehicle, any phases. So if I had, let's say I had a railroad going right through the middle of that intersection. It happens, it's not out of the realm of stuff. The track's going through there. The train will hit a switch a quarter mile away, and it'll start the preemption routine, but the routine will be to clear 10 seconds to clear everybody off of this that's on it, and then it'll go to the all red. So we want to run a track clearance first. Same thing, we have a ped clearance time that we can put in there, a yellow and a red. What's critical for those that are not using railroad is, again, we default to, the default is they put timing in the track green. It's a safety default. So it's your responsibility to zero those. In a normal preempt, you're going to zero these 4 guys out. If you don't, when you do a regular preemption, you're going to time that 10 seconds green delay. So you're going to be out there testing it. You're going to get the preempt input call to come on the processor, and everybody's going to sit and wait and be like, yeah, where's the preempt thing? It's because it's timing the track green. So we always want to make sure if we're not using it, we got to zero that out. And then this section is return to preemption. Okay. So same thing. How do we want to, when we return, do we want to time the ped clearance? Because when you come out of a preemption, you know, we're going to control what phases that we go cycle through because everybody just had to wait. So do you want him to time the design plan walk clearance, which is what we do, or does that want to be truncated down so we can get back into normal operation? And then the yellow and the red. So we have the ability to kind of truncate some timing. I always recommend, you know, going with the times that are on the plans. You can never get in trouble that way. God forbid there's an accident or something happens and they go back and look at the programming. You know, your time matches what's on the plan. So now the liability doesn't fall on you. Okay. So that's basically how we control the timing of everything. Now we're going to vehicle status. So again, we have we have the phases across the top, 1 through 6. And then we have 2 options. We have the track green, and then we have the dwell. So track green is we can control those phases. We have to control those phases that we want the track green to apply to. Otherwise, it can apply to nothing or all. So we designate it. So in our case, you know, we would put track green on, you know, in the example I gave, you would have did track green at 1, 2, 5, and 6. You know, sometimes it's just phase 4, sometimes it's just phase 6. Question?
You program the preemption to go into the last phase service before preemption.
So the question is, can you program the preemption to go into the last phase service before the preemption? The question is, the way you would do that is each preemption is servicing a different phase. So I made a little chart over here. So preempt 1 and 6 is preempt 1, detector 1, 2 and 5, detector 2, 3 and 7, detector 3, 4 and 8. So what we like, going back to what I was saying, if we preempt to 1 and 6 or 2 and 5, we like to return to the side streets of 4 and 8. So that way we're going main line to side street. And then if we're preempting to 3 and 7 or 4 and 8, we like to return to the main street. So the controller can only return to where we tell it to. It doesn't arbitrarily know. So if on 2 and 6, and let's say the last phase, you didn't have a lot of demand out there, the last phase was 1 and 5, was 1 and 6. So we had 1 and 6, and then we're going to preempt to 2 and 5. It doesn't know that it was in 1 and 6, so it's not going to go back there. It's going to go to wherever we program it to, which would typically be the side street. So it goes by, we try to offset somewhere different than what phase it was in. Again, if you're in 1 and 6, we might want to go to 4 and 8. But the controller doesn't exactly know where to go back to, where it was. Because that changes, because we skip phases, it's not a set sequence of operation. It goes by vehicle demand, so I can skip phases and go back to somewhere else. So hopefully that answers that. So the track green, again, that should be zeroed out if we're not using any railroad. And then we would just do the dwell green. So if we were doing my example, 1 and 6, which is my preempt 1, I would want to dwell in 1 and 6. 1 and 6 is the through and the left turn. So that would be my phases for preempt 1. You'll notice 9 through 16 are all 4s. That gets defaulted like that. If you look at the code underneath, 4 is dark because we're not using it. All right, so that's all you're going to really put. This screen tells you basically what phase you're preempting. 1 and 6, 2 and 5, just 3. One of the if you're preempting to an overlap, so let's say for whatever reason this phase was just an overlap, instead of being 1 and 6, it was overlap A. I wouldn't put a dwell phase in here because I technically don't have a dwell phase. I have a dwell overlap, so I would leave the 0. And program it in, I would program the overlap dwell in here. So I'm going to skip over PEDs for a minute. So here's another thing. If you notice again, this default, and I don't know why this is, but they default everything to a 4, which if you look in the code is dark. So what you have to do for at least overlaps A, B, C, and D, I recommend this, is we zero these out. A, B, C, and D are the most commonly used ones. We recommend that you zero those out just as a matter of your own default. So you don't run into a problem down the road on why an overlap is coming on, not coming on. If you just zero it out, it'll be red, and that's fine. We'd rather know that it's going to be red than question whether it's going to come on or off or not. So our regular standard is to just make them all zeros. But if I didn't have, in the scenario I just gave, if that approach right there was not 1 and 6, and we just called it overlap A, and I wanted to preempt it, then I would go into the overlap status, and I would put a dwell 1 under overlap A. So that's how I get my overlap storage. And sometimes you'll use a through, maybe just the left turn was an overlap. So I would put the 1 in phase 6 on the phase screen, and then the 1 on overlap A. So I can do phases and overlaps. So I can do just phases, just overlaps, or a phase and an overlap. It depends what I want my operation to be, or what the approaches are designated as. And then the other thing that you can do here, I apologize, let me go back to vehicles, is down below here is something called cycle. So this goes back to when we have a train crossing, when we have a rail crossing. So let's say my train, let me get my tracks out of the middle. Let's say my train crossing is right here. Okay? So the train only crosses this part of the intersection. So if you have a long freight train that takes 2 minutes to go through the intersection, it's only going 15 miles an hour. During that railroad preemption, I have the ability to move traffic on other approaches. So the train would be crossing here, but there's nothing to say that I can't have traffic go up and down this way, or traffic take right turns, take left turns this way. I just can't have anybody go through or take left turns over there. So we have a way that we can cycle phases during preemption through vehicle recalls, min or max recall, just regular demand off the detection, which would be fully actuated. So we have some options that we can we can maintain vehicle movement while a train is moving for 5 minutes and we don't back up all these other phases. So we use that every once in a while. We just don't have a ton of rail crossings in Mass, I mean in New England, that impact intersections, so that's why we don't use it. And then same thing with the overlaps. I can cycle specific overlaps, like a right turn overlap if I want to do that. So very useful, gives us a lot of flexibility. And then a trail overlap, same thing. When I had my example of 2 intersections, the green turns off here, but the green stays on over here. That's our trailing overlap. I can manipulate a trailing overlap as well. All right. So I skipped over PED status. So PED status, one more thing, go back over, okay. One thing that comes up, confuses people all the time, flashing yellow arrow, okay? Flashing yellow arrow, the thing we talked about in session 2, is when we have the 2 signals, and basically we have the green arrow comes up for our protected movement, it clears, and then once this green comes on, we have the flashing yellow arrow comes back on. All right, when we go to preempt the 1 and 6 there, remember the flashing yellow overlap is the flashing yellow portion is technically an overlap. So whatever overlap that we make it to get it to operate correctly, we make that a 5. Okay, if you look down there, you'll see that 5. I go to my next. 5 is flashing green. So the green doesn't flash, but we're just telling the monitor it's okay just to have. It basically it's saying it's okay just to have the arrow on and not the flashing yellow arrow portion of it. So we're telling the controller and the monitor how we want that arrow to operate, just like 1 and 5. But we want the phases 1 and 6 to operate properly, not the flashing yellow overlap portion. If we don't, then we can have an arrow that flashes. We can have an arrow that goes dark, and then you'll get a red signal fail. We've all kind of been down that as we learned how to program flashing yellow arrow preemption. But basically, if you put a 5 in, you should be good to go. I'll get that back out. So let's go back. Okay, PEDs. Same thing. We have a track green. We have a dwell. We can have PEDs do things during if we have railroad crossing. Again, you'll notice the default, they have the PEDs all go dark. We need to zero this out, okay? We've asked if they could change this, and they say it's a safety default. So we zero it all out. If you don't zero it out, what's gonna happen is when you go to a preempt, all your PED signals are gonna go dark, and you're gonna go into a red fail. So you have to zero these out. You'll see 3 is dark. We put it in 0. So basically they're just gonna remain in a don't walk. That's what we want them to do. That's what they've done historically. So make sure that you have these go into a 0. So I'll go back in and we'll program one event. So typically I'll say, okay, there's my 120 seconds. I don't want that call to last any longer than 120 seconds. As default, we kind of just throw in 1 second of extension just in case. And then we'll go down. So if I'm preempting to 2 and 6, I'm going to exit to 4 and 8. And I'm going to carry calls on my main street 2, 4, 6, and 8. Okay? Yeah? I'll go to my interval times, right? I put those all at 5. I think for this, I'm using my same program that I had. I believe my PED is, I think my clearance was like 16 seconds. I think it was 5 and 16. So I'll make those both 16. So again, just in review, our emergency vehicle pulls up and I'm in the middle and I'm in 4 seconds. I'm in the 13 second of PED clearance. It's not going to service that vehicle until I count down all 13 seconds. And I'll go into, I want to make it a 1 and 6. On my F. I got my PEDs all zeroed out. Again, don't worry about 9 through 16. It's 1 through 8, so we have to do that. And then my overlap, I don't have any overlaps, so we're going to zero this out right here. Okay. So now I have that programmed in there. I'll go back to my miscellaneous. I'll go up. I'll go to my screen down below. I'll do a test, and you'll see it goes right into preamp 1. Okay? So now it doesn't, it just shows preamp on that screen. If I go to the 1.7 screen, you'll see that my signal as well, it just went to 1 and 6, and it's already clearing out of 1 and 6 because I didn't have, because basically it was an instantaneous call and started timing the 10 seconds right away. But that's essentially how the preamp, how to program a preamp. Not super hard. And then basically you would just, as they say, rinse and repeat. You go to preamp 2. Again, there's the 249 for preamp 2, and you just replicate all that same timing except for your exit and your calls. That's essentially the preemptions. Now, if we go, if for some reason we have to use preamp 7, so the sequence of that would probably be if I had, let's say I had a bridge crossing, that would be preamp 1, and then maybe there was a railroad, that's preamp 2, and then if I had a firehouse, which had, you know, in some of the firehouses for you fire guys out there, we put in the consoles with the push buttons. Let's say I had a console that had 3 push buttons in there. So that would be 1 for the bridge, 1 for the railroad, 3 for the firehouse. So that's 5 preamps right there that I'm using out of my standard 6. So now I still need I still need 4 preamps for my 4 directions over here. So what I could do is I would use 6, 7, 8, and 9 for my regular preamps. So now I just have to figure out where to wire my preamp harness to, or what am I going to use? So I can use, so I have assigned vehicle detectors 1 through 64. I could say, you know what, I'm going to use the last 5, 59 through 64, because I never use that, or special detectors, because I never use that, or, you know, the PED. So let's say we use the special detectors. I would probably do 65. So now preamp 7 is going to come in on 75. So I just have to make sure that I program special detector 65 in as a time I preamp input into that. Might be a bad example because it's hard to get to. If I did PED 8, which would be 80. So when we use, for a good example is when we use a 760 rack, so we have the harness coming down, I would take the preamp, in this case, the preamp, whatever preamp 1 or 2, and I would put that on PED input 8. So now when a preamp comes in, I'm using that 8 to get this to preamp activate. So that's a situation where we can use these other 6 unused preamps to get a full complement of preamps. So I would have 5 with bridges, railroad, and fire station, and then an additional 4 with my standard intersection preemption. So I'd have a total of 9 preamps at this intersection. So we're not limited anymore. We used to have to go try to use the priority ones over there. Didn't always work out great. So that's an example of how we would do that. Let me go zero this back out. So that's our standard preemption. One thing you guys are generally good at is when you do swap out controllers, a lot of times people are familiar enough to get the preemption back in. So if the original controller dies, we put the replacement in. Most of us can get some type of preemption working, maybe not on all 4 approaches, but at least on the main street. But you see that it's not, it takes a little bit of practice. I never like to say things are easy. What's easy for me and it may not be easy for you. But with a little bit of practice, you know, you can kind of get something back in there working so fire doesn't complain, you know, that's an intersection isn't preempting anymore. Okay, so that's the preemption part. Let's go to the priority part. And I'm not gonna go crazy with this because there's a lot involved and I wanna make sure I have enough time to cover everything. So again, my priority, traffic signal priority, covers bus, light rail, plow, Sanders, funeral vehicles. All right, and it's a delayed transition. So there's a lot more programming on how we get into this and how we get out of it. So we only have 6 priorities, we don't have 12. All right, so same thing. So I go in, and now you have all this different data. You have detection, service, transit, signal. There's three terms that apply to priority. Let me cover this one. So basically, if you wanted to set up the detection, you could assign, you put a time in here, you can do a delay or an extension. Down here, we have what we call advanced detectors. So in the scenario of a bus, we set up a bus that has basically a detector there, and potentially a detector there. And as the bus gets closer, we assign timing values to let the intersection know where the bus is and how to manipulate the timing. So all we're trying to do with priority is hold the green. So if I'm in the green and a bus is coming and it triggers one of these detectors, all I'm saying is stay in green a little bit longer so my bus can get through. Stay in green a little bit longer so my snowplow doesn't have to stop. Stay in green a little bit longer so the funeral vehicle can go through. All right? Now, if I'm in the green, it's easy. We just extend the green through some of this program, okay? If I'm not in the green, how quickly do I want to get to the green? So the 3 levels are minimum, partial, and full. And that's the impact to the intersection. So each level basically is what it is. Minimum has minimum impact on how it gets back. So basically it says, okay, a bus is coming, finish your phasing here, time your whole phase green that you have over here, and then we'll go service 5 and 2. Partial, maybe we only want to do partial of the time and then get back to 2 and 5 for the bus. Or full, that's the most aggressive, where you're almost treating it like a preemption, basically get the heck out of this and go to my green. So in each intersection along an arterial, we can control how we go into that priority differently. So we could be more aggressive on one, less aggressive on the other. So just some of the terms that they use. TSD, time of service desired in seconds. That's the time from detection to the co-phase green. So that's what it's going to do, is it starts hitting these phases. Time of estimated departure intersection. How long does it take the bus to clear the intersection? And then time to live. This is how much it'll stay in the queue. So there's a lot of acronyms. There's a lot of going on. If you ever have a bus application, we'll be happy to sit down and go through all this with you. It's a lot. I just want to expose you to it. Mainly the difference between preemption and priority and how we do it in the controller is something that you need to make yourself familiar with. Is priorities becoming a very prominent thing because we're doing this TSP out there. And if you live in a town that has priority and you're changing controllers out, you need to understand that you have to get that information back into the controller, because it's critical. Once it stops working, the bus people are going to know right away, because everything's going to fall off schedule again. So if any of you fall into that, I'm more than happy to kind of go over that, because TSP, like I said, it's pretty involved. There's a lot going on there. It took us a little while to kind of understand it. I just don't want to take up a lot of this class time with it, but I want to expose you that it is out there. Okay, so that's basically the difference between preemption and priority. Okay, what is it? So that was good. So that was an hour getting through. Let me grab a quick drink right here. I appreciate everybody coming in today. I know the weather's pretty nice outside. All right. Now we'll go move into a couple of the other things. Okay. So system data. Right. So these are for the folks that have closed loop systems. we talked a lot about, in some of the previous classes, IP addresses and IP networking, because that's kind of what we're transitioning to. But we still have a lot of closed loop systems out there that just basically need local addresses. So this is where we would do that. So under communications, if you had a closed loop master at one intersection and you had 4 intersections, you had copper interconnect between all of them, the master needs to identify those 4 locals. So we would give them a local address. So basically right in here, we could give it up to a 3-digit. So right now I have a 1 in there, but I can make it, you know, whatever I want. So I gotta leave it at 1 because that's part of my connection that I have for what you're seeing on the screen. But typically I would make location 1, the next one be 2, the next one be 3, the next one be 4. When we go into the master, we program in location 1, and it actually has the street address. So location 1 is Main at Elm, location 2 is Main at Oak, location 3 is Main at Pine, location 4 is Main at Sasquatch, or whatever. So that way you can identify the intersection. So when I'm in the master controller, I can click on those addresses and actually pull up the front screen of that local address, assuming we have good communication between master and local. As we get in, and why I have the 1 in there now, this will be key as we do some classes on uploads and downloads using the Siemens Tactics software. When we start teaching you guys how to do this over IP, you have to have a 1 in this address, otherwise you'll get a COM error. So something to keep in the back of your head, it'll come up again to you as we start to kind of educate you guys on transitioning from serial uploads and downloads into IP, which I think a lot of you will really appreciate. Really, that's for the system communication. There's a lot of other tabs on here. I'm going to stick to the main ones that you guys would use. Traffic responsive. This is something that gets used very infrequently. It's a form of I don't want to say a form of coordination, but it's a form of how we can judge traffic going in intersections and do collection. So when you have system detectors out there, right? So typically you'll have, when you guys are out, if there's any contractors, you guys are cutting loops, a lot of times you'll have departure loops. You'll have like 2 here, 2 here, 1 in each lane. So they're the outbound going over there. So what they're doing is they want to count the traffic that's passing through the intersection. They want to do data counts. So in here, we designate, so again, vehicles, you'll see 1 through 64. I'll designate certain vehicle channel assignments, and instead of putting phase assignments where I normally would put in, I would put them in here. So let's just say I'm using 7, 8, 9, 10. Oops. So the way that would work is this would be 7, 8, 9, and 10. 7, 8, 9, 10. Right? And then after I do that, I have to put some timing parameters in here. So this is vehicles per hour used, average timing in minutes, occupancy correction factor, and then minimum volume presence, right? So I would put some values in here, similar to this, just to kind of put something in here. And this tells the controller when to count and how to collect that data. And then that'll all come up in another screen that I'll show you, where it'll basically, how you can pull all the logs and collect that data. So traffic engineers like to use that. This is a big part of how we do adaptive signal control. This is the way we put the zones in, so this intersection knows what traffic is coming to it. So again, just wanting to make you guys aware of this when you hear people talk about report parameters. Typically they'll say, you'll hear the term binning. We bin the data every 15 minutes, every 20 minutes, every half hour. It all depends on when they want to pull that data out. So 15 minutes is kind of the standard for that. System queue, again, we don't typically use that, so we'll leave that out. This is an interesting screen. So our local alarms, when we do troubleshooting, and I'll go over that in a little bit, I always have you go to the main screen FFF, and then 0 for reports and 4 for alarms. And that's where you guys tell me, you know, if we have BIU failures or diagnostic fails or what have you. We can actually, the default is to, here's where all these reports come from. And if you notice, they all have a 1 to log it, to log everything. And if I go back the other way, you'll see that I have the option to do 424 of these things. There's a lot of things that can be put into the log. We had an issue with a revision of software for GPS. GPS being the GPS time sinks that we were putting on the controllers to keep in step with the coordination. And what was happening was the satellite GPS clock was fighting with the internal clock in the controller in that revision of software. So when you guys were going to the event log, some probably saw this, not all, you kept getting a time clock fail. So, but it was basically like every second or every 2 seconds, it was generating a fail because the internal clock was trying to override the GPS clock and it couldn't do it. So the one thing, they knew that that was a bug, that was a problem that they had to do a bug fix for. So we didn't clog up the event log. We would actually go in and it ended up being alarm 86. So we scrolled all the way down to 86 and just turned it off. So then it didn't log it anymore. It wasn't doing anything. We just didn't want it to clog up the alarm menu. So there's a way that you can turn them on and off. I don't recommend that you do it. If we have a situation where there's one that doesn't do anything, we can turn it off. But I just wanted to kind of show you where that is. And then it's just another way to get to the alarm report, which I can show you later. And here was showing me as I was playing around with the clock yesterday, playing around with where I was finding out why we kept getting the bad chord plan. Okay. So that basically covers the system. Again, the main thing is the address. Nowhere to put the address for a local, and when we start doing IP uploads and downloads. And then, so again, as I just mentioned, I will have you with troubleshooting. This applies more to TS2. And just, I haven't mentioned this yet, but I already made a video. It's a short 15-minute video where we went out to a TS1 cabinet, and it kind of just goes over the TS1 cabinet. And I'm going to do one hopefully maybe today or tomorrow on a TS2 cabinet. I'll send those to you guys, so you'll have a general idea of, you know, the difference between the two cabinets. So this TS2, TS1 comments that I keep making will kind of make a little more sense to you. So we go into the reports. I'll say go FFF to the main menu, go to reports. In older legacy software, reports is 9. In this one, it got, because we separated preempt and priority, we had to push everybody else forward, so now reports is 0. And I would say go to 4 for the alarm menu. And here's the same screen that we had before. And basically you'll see it gives you a month and day and a date and a timestamp. So it tells us, this is why it's critical to make sure your date and time is accurate, because when we have problems, we're going to troubleshoot, we can pinpoint it to exactly when their problem was reported to you. So in here, we just happen to get no cord, bad P is planned, bad plan free. That was due to because I had taken things out of the ring structure arbitrarily to show you something. It'll give you all sorts of things: power on, power off, going in and out of coordination. I had my preempt. It did it logs the preempts when they go in. If I was tied to where it becomes very useful in a TS2 setting, and I'll show this in my other video, is in TS2 where we have the controller and the MMU and the BIUs all connected. Anytime there's a fault between those devices, it'll register that device. So when our BIUs go bad, and there's 3 of them, it'll give me a frame fault code number. And that code number in the back of a Siemens manual will tell you, you know, 147 is BIU 1, 148 is in the rack, 129 is the MMU. So it helps you identify which device is giving you the problem, or it could also be the harness that is the problem, the SDLC harness, because it's not, has the ability to communicate that information, is a breakdown in the communication. So, so a lot of times I'll have you go to the screen. You guys should be familiar with the screen. It just kind of pinpoints what happened. If this was tied to a door, the door alarm would active. It'll say whatever it is, aux 1 active. I forget what I should know this, but so basically, if you want to know, did somebody go in the cabinet at this particular time? It won't tell you who, but at least it'll tell you that the door was opened by somebody, and maybe you do a little backtrack and you can tell it was one of your staff, a consultant, a contractor, somebody was out there. If they were in it, they've probably been in the area. So it kind of helps you pinpoint that. So it's a very important screen that you know how to get to. So again, from anywhere in here, any screen, I can just tell you to hit the F key 3 times. You'll get back to my main menu, 0 for reports, 4 for alarms, and boom, you're in the local alarm reports, okay? So comm faults, again, we're not tied to anything, so that really doesn't help. Some of these screens aren't really gonna do much because they're not in an actual cabinet. System detectors faults, the MOEs, this screen ties directly to where I was setting the information for these detectors. This is where that data comes up. MOE is mission of effectiveness. Basically, how many cars do you have traveling through the intersection? At what speed are they traveling? And what is the green time? Does it all balance out? Or do you have too little green time? Do you need more green time? What do you need to do? So basically, that's kind of breaking down the effectiveness of how that intersection timing is working. Speed, cycle analysis. The other important one is MMU cycle flow. So here's another screen. If we were tied in TS2 to an MMU, this screen where it says FLT, red, yellow, green, would all be populated with 0s or 1s. So if I was in 2 and 6 green, I would have 0s on the red, yellow, green. It'll be columns of 3 zeros. I would have 1s on all the reds, 0s on everywhere else, and a 1 under 2 and 6 green because I'm in 2 and 6 green. And that would be a working thing. If I was missing a 1 on the 2 green, I would probably have a red fail or something of that nature, basically saying that's where my problem is. So this can help pinpoint what phase, what signal identifier is failed, so you can start troubleshooting in the field that way. So again, I'll show you this. Watch the TS2 video. This will make a little more sense because it'll be tied to a cabinet. And then again, this would give you the peer-to-peer functionality if you were doing that. So that's some of the reporting. You know, very helpful screens. You know, tough to demonstrate in this scenario, but again, and I'm sorry I keep reverting back to. That's why I want to do the TS2 because it'll make more sense over there. Now I'm going to go to, so we kind of covered everything. This is where you start. I'm actually finishing with one, but active status screen. So these are key that you understand how some of these work because they can be super helpful in the troubleshooting. And when we're troubleshooting over the phone, you'll hear me say, okay, go to your active status screens, go to 1. And then typically I'll say, go to 111. So from the main menu, go 1, active status, 1, ring timers. And then this menu allows you to watch 2 rings at a time. So again, this is a 4-ring machine. I can watch any 2 rings together that I want. 99 times out of 100, we're only watching ring 1 and ring 2. So that's why I say go 111. And that actually brings us to the screen that's down below. Here's my ring timer screen, where basically, I'm going to go back one because I always find it confusing to look at the screen twice. So starting at the top, on the top left, actually in the middle, you'll see it say ring 1, ring 2. So and you'll see right now I'm timing ring 1 and ring 2 concurrently. And right now I'm in 1 and 5 is on. I'm transitioning to 2 and 6, and I'm 2 and 6. So I have ring 1, ring 2. I have min green, M green. If I didn't have calls late at night, I would sit in green rest if I didn't have any detection. Everything's on recall, so it's going to cycle through. It's resting in coordination. I will explain that. If I was running max 2, below where it says green rest, you'd see a max 2 pop up, a max 1 or a max 2, which would be our extended green that we went over in one of the first classes. In the middle, it says ring timers. Again, B is the bank. So we're in 111. That's critical that I mentioned. If you're programming and nothing, it doesn't seem like the program is reacting to what you're doing. If that says 211 or 311, you're in the wrong bank. And I showed you how to go back to changing, getting right in the bank that you need to be in. Remember, phase data is bankable, unit data is bankable. There's a couple of other ones, but those are the main 2 critical ones you want to know about. So phasing goes across the top, 1 through 16. And then the next line, you'll see it say O/N. Simply O means on, N means next. Okay? So we're either on a phase, not doing anything with a phase, or we're going to the next phase. And why that next is critical is once a controller makes a decision to go to the next phase, it has to go there for the minimum green, yellow, and red time. So that comes back to, there was conversation about if I have demand on 4 and 8, and then the vehicle, I don't have any vehicle demand on 4, and a vehicle pulls up on 3, and the controller hasn't made the next decision to go to 1 and 5 or 2 and 6, then the controller can service 3. It can bring 3 up, and we can do 3 and 8 because 4 is not on. If the controller already makes the decision to go to 1 and 5 next, and somebody pulls up on 3, it's too late. 3 has to wait until it comes around again. So that's the term we say, the next decision. The controller's made it's already made a next decision to go to somewhere else in the sequence. Then you have the next line, which is vehicle. So that shows recalls, next, vehicle calls. Same thing with the line below it is PED.
I keep all my emails.
Close that door if you're done. The PEDs, that'll show the calls if you have PEDs coming on next. And then this bottom line, H/O. So baby, that basically stands for either hold or omit. So the hold is only going to be used during coordination. So right now, we're gonna go into 2 and 6 because 2 and 6 is my coordinated phase, and we're gonna hold in 2 and 6, meaning that we're not actuated, and we're gonna hold in 2 and 6 for that 45 seconds, like we talked about in the coordination class. And when we do that, we basically omit all the other phases because we don't care what's going on anywhere else. You're gonna get that guaranteed green time in my coordinated phase. And then once we leave 2 and 6, the holds drop out, the omits drop out, so now we can start servicing the other phases. So right now, we have extra cycle in the cycle length. So a lot of extra time is going at 2 and 6 out of that 100 seconds because we're not timing the PED. So that's going to start cycling around like that. So that's the hold in the omit. The key with the omit is unused phases will have omits on them. So if I set this to free, it'll work a little bit differently. So again, I'll go through my programming. I'll turn that off. What's that?
Question. What's the P?
What's the P? Jim Petruzzi, what's the P? What do you mean by what's the P?
What are you?
There was a question that
Under H/O.
under H/O.
It's not there now, but
All right, so let me go back. Maybe it was that came up in coordination. But right now, so if we go to hold and omit now, you'll notice I'm using all 8 phases. So there's no omits on 1 through 8, and then 9 is our exclusive ped. We only have O under 10 through 16, because we're not using 10 through 16, so we omit them, we turn them off. If I weren't using phases 1, 3, and 5, I would have O's always on 1, 3, and 5, because we're not using them. But in this case, we're using a full complement, so it's all over there. We're not running coordination, so we're not using holds. So essentially that line for this is only being used to omit the phases 9 through 16. Let me go back into the coordination. So you see once I turn coordination back on, the you'll see the coordination timer start timing. And I'll look out for the P, because there was a question on what the P was. Pretty sure it's only O's and H's, but if it pops up again, Jimmy, let me know. Just watching it for a second to see if I can see what his question was. The N under PED means non-actuated. That means that we're resting in the PED right now. Nobody hit the buttons. It's coming up because of the coordinated phase. So we're resting in 2 and 6 PED right now. Down below, you'll see under ring 2, green rest, we forced off because we ran through the time, so it forced out of it. And again, we have the hold right in the omits. Okay. Oh, the P's right there. Oh, so that P is the permissive window opened. So basically basically it was looking to see if that was open. So yeah, the P's do come up. I apologize. Basically it's saying it pops open to see if there's demand there because it has on recall. That means the recall is simulating vehicle in the van being there. So that's the permissive window open and closed. Thank you for that question. Okay, so we'll go to, again, active status. So that was ring timers. We'll go to core timers. So this is a pretty cool screen. This is one of the benefits. So I can actually watch the coordination down below and see what's going on with my coordination timing right now. So you'll see at the top, I'm in backup. If I was connected to a master, it would say system. If I was connected to anything, it would say system. I'm on backup because I'm essentially just running time-based right now. And I'm in 111. And then across the top is permissive max to beginning of plan, beginning or end of plan. That's telling me I'm running permissive coordination. If we go back into the coordination settings, permissive max to beginning of green and plan force off. So I kind of have an idea what my method of coordination is in case I forget, or I don't have to go back to that screen. The cycle is 100 seconds long. My offset is 10 seconds. You'll see the time below the 100 that's counting with the seconds, that's counting my cycle timer down. The minus 18 adjust. So basically we went out of step. So that's what we're trying to get back into steps. You'll see that's the short wave calculation, the correction. You'll see it just dropped down to minus 6. So it's adjusting 6 seconds one way or the other. So when we come around to the cycle timer again, when it gets down to 0, that should snap into 0, and then we know in step. So technically we're running coordinated right now, but when you have a value on the adjust line, that means we're trying to get in step with itself. So my cycle length is being manipulated to try to get everything back into step. So that's because I turned the coordination off and turned it back on, which is what is causing this. And then you'll see, you have your ring 1, your ring 2. It's telling you the timing that's active, the phases that we're in, 3 and 7. It's looking at the permissive of 4 and 8. If you look down, now we're in 4 and 8. So there's a lot going on. It's a busy screen, but very helpful that you can sit there and watch this while you can watch the timing down below. We'll see if when we get down to 0, we should pop into a 0 for adjust, and then we would be in in step, as I keep referring to. So give another 7 or 8 seconds. 2, 1, and boom, hey, look, it worked. So now we're in step. So now we're completing step, so we want everything. So now once we're in step, now my offset is gonna be accurate to all the other intersections that are down the street. So that's key. So when you're doing coordination, it's key when you go reference this stage. The thing I always look at first is my adjustment to make sure that I'm in step, and then I'll start looking at some of the other values. So helpful screen. My preempt and priority screen. So basically I can go in. So here's a screen where if I did a preempt, then let me activate it from over here. Oh, I just did the same thing. I can't do that. Let me check. Look at this. 7, 1, 1. So I went to preempt, FFF, active status 3, 1. So now you can see where the dwell green timer is counting down up on top. That was the 10-second value that it's going through, and then we're going to time the yellow, we'll time the red, and then we'll go back into, you'll see where it says RET, that's the return yellow, that's the timing that was on the right side. And then you notice we're in the lockout, so here's where we got thrown out of coordination because we went to a preemption event. So now it's going to, based on whatever I had programmed in there, we're going to service those phases and go back through, and then it'll try to get back in step, and we'll start that correction again in the coordination screen. So the active status screens kind of tell you what's going, it tells the story of what's going on with the controller, what it's thinking in its brain. F. Okay, so and then priority timers. So same thing. If we were doing TSP with the priority, there's a number of different screens here that we could come on, do the timers, the detectors, the status, the phase utilization. There's a lot going on with priority, so depending on what information we're looking for, we can go see it in one of these screens over here. Time base, another good screen. So this is, again, active status. So it's what's going on second to second in the controller right now. So you'll see the date Tuesday, 5/19/20. Yep, I updated that right. 11/24/23. Time looks good. Daylight savings time. We're in day program 3. That's fine. And we program 0. That's fine. Traffic. So we have traffic and auxiliary. So basically these are our 2 time clocks that we have. So our traffic events or auxiliary events. So in traffic right now, we're running dial split offset, DLSPOF is 111. If you look down below, it'll say backup 111. So we know that that's right. If we look over, and then if we look down below, it says P semicolon with all dots. We're not running any phase functions. If we had phase functions like max 2 or something on, then that line would be populated telling us what phase function we're using. If you go to the right, it says auxiliary screen. Again, we have the 3 auxiliary inputs, we have the 3 detector, and then we have the 8 special functions. The DIM, dimming, we're not using dimming, so it says no. So if we were using anything in time clock settings, let me just go back quick. So we would go to 6 for time-based data. So 3 is traffic events. So here's the traffic event sides, which is telling me the 111. This traffic events correlates to the left side of the screen where it says traffic 111. Kind of going back and forth. If you go to auxiliary events 4, right? We don't have anything going on here. Here's our auxiliary, our dim, our special functions. If I go back, we go to the right side, which is auxiliary, it's all just stars because there's nothing going on over there, right? And then the code tells you know the number, the off, not defined. So it just means that we're not doing anything. One good thing to know is if you want to know what the actual time of the control that it's timing, go to this active status screen. Because if you go here to set time, you'll notice that's a stagnant time right there. So that's not, it's whatever the time was when I got to the screen. It doesn't toggle through. It's telling me it's a timestamp time essentially. So if you want to know what the active time is, you've got to go to the active status screen. So now you'll see the time clock timing down. Okay. Communications. All right. This is where we would check our signal comm. So going back to that master and closed loop scenario, if I'm at one of the locals and I have, you'll see it says port 2 and port 3, and you'll see the settings. So in my controller, the baud rate set to 1200, 8 N and 1, my status, I'm online with 2, I'm failed in 3 because I'm not connected to anything. And then my carrier inactive. And then I see transmitting and receiving. If I have a local controller tied to a master, typically if I'm doing closed loop over copper, I'm using port 3. So what'll happen is the controller polls, whatever it is, every 30 seconds, the master polls every 30 seconds or once a minute. And basically you'll see data come on for transmitting and receiving, and you'll see data on the top line and receiving will say acknowledge. And you're really gonna look at that because it comes up really quick and it's only up for like 3 or 4 seconds, but you'll be able to see the data going back and forth. Same thing if we do any type of the old spread spectrum radios, we used to communicate on port 2. So that data transmission would be in the port 2 because that's the port that we were using. So here's a good way to see if you have data communication going back and forth. All right, IP configure status. So basically this is telling me with the settings, a quick screenshot of the IP settings that I have in that controller. So my IP address, 192.168.1102. My peer-to-peer status, right? I'm not using any peer-to-peer functions, so this stuff is all empty. If I was using any peer-to-peer, this would be populated with data for that, turning preemptions on or turning recalls on. And then this is kind of a neat one that they do is, got a little happy fellow walk by, ping utility. So again, this comes in handy with the IP addresses. So if I'm doing Ethernet radios, everybody has an IP address. So I'm going to put an IP address, right? So basically, by putting the 1 in and I got results, okay, I put in the IP address of my controller. I was trying to ping myself, basically to see if I'm out there. I'm connected to a switch right now. I could ping that switch to see if I have connectivity from the switch to the controller. I could ping other devices down the street, other controllers, other radios. It's important to see if we have this connectivity in our cabinet and going down the street. So it's a quick communication test that we can do. If it comes back, it'll try 3 times. If it doesn't work, it'll say fail, fail, fail. Now I start after troubleshooting my settings, my connections. Do I have it connected the proper way? The programming could be right. I just might have it plugged in the wrong places. So as we start to educate you, or you self-educate you on IP addressing and network, the ping device will become very handy. It's a very good troubleshooting tool that you can use. All right, detectors. Here's another one. You can go in and kind of check detector status. Some people use this screen. I don't tend to use it that much. Some of the codes down below, where they give them, because people don't always know what the codes mean. So I think that the codes kind of create more confusion than what they were. Some people swear by it. Basically, it gives you the status of, you have a watchdog fail. If you have, I don't know what happened to me. Yeah, so it's not going to give it to me here. Because I just use it infrequently. But if you look at the manual, it'll tell you what each number does, and it's just a troubleshooting guide to kind of pinpoint you to what the problem is. I always felt like detection, it's kind of go or no go. You can kind of tell if it's working, if it's not working, and then from there, but there's so much information on the amplifier or in the video detection system or in the radar system that can basically pinpoint us to what the problem's going. I no longer have to look for that information in the controller. I can get it off the detection devices is where I go to get my information on why something's working or not working. So it's a personal preference. A lot of these screens are. Here's one I like to use a lot. This is called intersection, number 7. So what this does is it gives me all my, so the vehicle signal and the PED signals of where they are in the intersection. You'll look across the top, it just simply uses the letters R, W, Y, G, and D. So right now, if you look down below, I'm in 2 and 6 green, and if you look up top, I'm in 2 and 6 G. Everybody else is red. So I can see where I am. My PEDs were all in the don't walk, and then if I had overlaps, I would have overlaps active, A through P. So that would be green, yellow, or red. And then the 2 critical lines are V call and P call. So V call specifically, we use this a lot with video detection. When we set it up and we program it, as vehicles go over the detection zones, we want to make sure that we're getting an accurate actuation under V call. So you'll get a C come on. So this works exactly with the vehicle demand. So as vehicles cross over your detection zone or your loops, you'll get an indication of a C on here. When the vehicle leaves off it, the C drops out. So it's an active status presence only way of troubleshooting your detection. The reason is down below, depending if you have things set to memory or not, they'll be cold. They're not really active on the lower screen the way they are on the upper screen. And then the P call is PEDs. This is the #1 troubleshooter when you have a bad PED button. Basically, somebody's going to get a call and say, the PED's coming in all the time. So I'm going to say, go to the screen, go FFF, go 17, and I'm going to say, see the line that says P call? Do you have a constant call right there? Do you see a C on it? Because when somebody hits a push button, the C should come on and the C should go off. If I have a constant C over there, that means I have a stuck button. For the older ones, you have a stuck button. For the APS buttons, you probably have either a bad button or a wiring issue that's grounding it true all the time, so that's staying on. There's one circuit in the controller, this goes to TS2, is your 12-volt AC circuit. Its main responsibility in life is your pedestrian circuit, 12-volt AC. If you blow the fuse in that, you can see a problem on the screen. So the V call and P call are critical when you're troubleshooting constant calls or no calls. I was working with somebody 2 weeks ago. They called up and they were seeing, they had got a complaint from a higher up that they waited, 2 or 3 cycles on a side street. When they went to the amplifier, we were troubleshooting it. So you'd see the light come on the amplifier and it was inputting a call. But then as he's sitting there watching the screen, all of a sudden the call dropped out. So basically it was inputting a call, which was great, but then it was dropping out. And the reason that we feel is just that loop was old. It had already had its sensitivity turned up and it just wasn't able to sustain a presence call. So in that scenario, we just put it on locking memory because it did get the call once. It just the loop couldn't hold the call. So we put it on locking memory. It got the call so it could service every cycle. But then it would drop out after that. The downside is you're going to get those right turners again. They're going to pull up. So it's going to service for the min, but not for the max. So that's a very important screen. Get familiar with that. It's one I always tell you guys to go to when we're troubleshooting over the phone. Port 1, yeah, we can't use that because we're not tied into it. Here's another one, input output. So basically this is a screen where we can see we have input outputs being active. And again, this is a newer screen. I like to use that last screen, the 7 screen, but this one is becoming very helpful too. So basically this is telling me vehicle detection by channel, where the other one's kind of telling us by phase. This is telling us, again, the difference between phases and channels. When I come up with a good example without even trying, right? This is telling me, you'll see it says phases 1 through 16. So I'm monitoring vehicle calls and PED calls by phase. On this screen, I'm doing it by channels, 1 through 16, 17 through 32. So I can now go from a phase to a specific channel that could be giving me a problem on that phase. So I have 4 channels of detection for one phase. Now I can troubleshoot those 4 individual channels. So it's just another layer of breaking it down. Off to the right, you have a couple of abbreviations over there. ST stop time, IA is initial advance. So we have our MC manual control enable, so we can see if that's going active, whether it's if the switch isn't grounding the input properly, or maybe it's our manual cord has just broken down and it's not making a good contact in there. So that's a place that we can see that. WRM, walk rest modifier, RR, red revert. LF is, I like to say, it's line frequency. Most commonly it's line frequency. But basically those just, if this was working actively, you just see an asterisk come on and an asterisk go off. Or you could see a 1 come on or a 1 come off. So very, very helpful screen. You'll see the PED detectors. You'll see the preamps. You can see if your preamps are going in. Again, let me do I'll do the preamp. We'll see it pop up over here. My little preamp test. To 1. FF 195. My preamp 1. And my preamp 1 detector. I think it's my preamp. I think, because again, I'm doing it in the controller. It's not getting the hard input because I'm not tied into a cabinet. So yeah, that's why I got to ground all these are grounded inputs that I can't recreate because I'm not in a cabinet. Again, referencing when I go and do the video, I can show you how this works. So again, that's a very important screen. And then 0, again, we're not hooked to the port. I don't use this one that much. So, and just going over your active status screens, some of the key ones, basically everything on the left is pretty important. Ring, cord, preamp, time and communication, and then 7, intersection, and then the input output, which is 9, and then 5. Those are pretty critical. Ones I'll commonly have you guys go to as we're troubleshooting stuff. It's ones we use on a regular basis because they just give the most information. So if I go back to main menu, I believe I have just successfully covered all the stations, departments, sections of the M60 controller. Again, I was trying to keep it to 4 parts. We get a little bogged down in the beginning, but we kind of picked it up. If anybody has any questions on what we covered today, if you have any questions I can answer questions. It's 11:20. I mean, it's 11:40. So we got a few minutes here. If you've got questions on some of the other ones, if you've got questions on something you're working on today, feel free to ask. Let's see. Right soon. I feel like a lot of people got stuff going on. Just looking at the calls, but that's fine. Again, we videotaped everything. Basically comes up as a YouTube video. The first of the month, we'll be launching the new website. It's pretty cool. Me and Wayne are doing a lot of work on it. So that will have a lot of information. We'll have a section that'll have links to all the links that I'm showing you will be there. Any videos that we do, we'll record and put them on there. We're going to try to we're going to start doing some vendor trainings, and we're going to try to get those recorded and put those on there. So the more stuff we can save to the website, and just a heads up, because this is all, it's all work that Ocean State Signal is doing, and it's specific to Ocean State Signal, and the vendors is this section is we're going to have a sign-in page. So you won't be able to just go there and access this data. You're just going to have to go in and enter like an email, and you're probably going to get a password. Is that how it's going to work?
problem.
Yeah, so it'll be somewhat password protected, because I just don't want every Tom, Dick, and Harry going in there and taking the stuff. I mean, we put a lot of effort into this. I want you guys to have it. It's for your use. I don't need somebody in the other part of the country using my stuff, and then, you know, it goes down the wrong direction. So they'll be password protected. Once you get a password, then you can go in all the time. A lot of our vendor sites, they're password protected to get to what they call the partner portal. It's where they put all the proprietary stuff. So we just felt like it's good, and then we can kind of track who's going in there.
Question from Jim. Can you program the bus preemption to shut off if the bus stops to make it pick up in advance of the signal as to not cause backup for limit preemption?
So the question was, in bus priority preemption, can you cause, what happens when the bus stops, essentially, so we don't hold the signal or manipulate the signal? So two answers to that. The way we control the timing of that is with those advanced detectors. That's why we have the time before arrival. Depending on where the bus stop is where it impacts when it activates the priority for the bus. So it kind of knows, we kind of time where the bus is to where it needs to be green in the signal. One thing that's happening, I know Jim's in Worcester, is this is the reason why they're moving a lot of the bus stops to the far side of the intersection, because it's less impacting how that phase is working, and then obviously people that are taking right turns, so it doesn't back up the right turn. So we can kind of control that through the programming. It's nice. That's why, another reason why they broke up the priority, that whole priority options, is to control things is what you're specifically talking about. Because we don't want the priority is an enhancement for the bus, and we don't want to inhibit the intersection. You know, we want it to be a smooth transition in and out. Because we know when sometimes buses stop, if it's a handicap bus and you're going to pick up, that can be, you know, a little bit of a time delay. We don't want that impacting how we're going to do it. So if it stops at a certain detector, it's going to be a lot longer time before it gets there. If it leaves there and hits the other one, then the intersection knows, the controller knows that, oh, the bus is on time now, so now we can get to the priority.
Could it hold the preemption if the signals are too close?
Could it hold the preemption if the signals are too close? Could it hold the preemption? You put preemption, so could it hold the preemption? Yes. And speaking to preemption ideally works 2,500 feet. So if you have multiple intersections outside of 2,500 feet on a straightaway roadway, I could preempt intersection 1, 2, and 3 all in one shot. And basically, I'm holding the whole thing. If you have intersections that close together, that's a benefit, because you're clearing out the queue of all the traffic to get emergency vehicles through those intersections. You do have the ability to delay. The thing you have to factor in is there's a side street or a business that pulls out in the middle of that 2,500 feet. You've now lessened the impact for it to get through that particular intersection. So when intersections are on top of each other, it's a benefit to preempt multiple in a row, because it just moves the queue of traffic going forward. From a priority aspect, priority works solely off those detection zones. So we set up what we call geofences. If we're doing GPS, which most of them are right now, otherwise it works off an IR emitter, and then we control it through the timing, how we get to it. The one we did in Rhode Island was all infrared. So basically, as far as the emitter can transmit to get, so yeah, you could do multiple ones, but again, we're controlling that we can control a little bit better with the TSP, because the preemption is instantaneous. So. The question was, would it be better to control peer-to-peer? Would it be better to program peer-to-peer for preemption? No. In most cases, no. In most cases, let the preemption equipment that you're using work, because peer-to-peer a lot of times will happen where it could happen 98% of the time organically and be fine. you could run into a situation where peer-to-peer is a program function. So if something crazy happens outside of the scheme of what we programmed the peer-to-peer to do, then you could impact how the preemption is working. So if you were going to go to peer-to-peer schemes, you'd have to think of every possible scenario that could happen, so it's covered under peer-to-peer. If you leave it as preemption, then it just works organically how the system goes. But there's always those specific application where we have peer-to-peer as an option for enhancement, or if we don't want something to happen, we can block it out with peer-to-peer. You may have an intersection where it comes up to a major intersection and we want to block out the farther one down. We could block it out with peer-to-peer so that, for whatever reason that is, we have the ability to do it. But that would be a unique application. So peer-to-peer can be used to block it out, but 98% of the time, traditional preemption is probably your best bet. You try to get, as they say, too cute, it always seems like we create a scenario that we can never account for, and that's the day that something happens. So just keep that in the back of your mind. We have a lot of tools in the toolbox for specific applications, that we can definitely take advantage of. We just have to make sure that we cover all our bases when we do it. But good questions, James. Peer-to-peer would be best to use on shop turns. Peer-to-peer would be great to use on shop turns in lieu of advanced detection. If you have, because you had IP connectivity, then you could take that. That's why the GPS does, the GPS and the IP networking, because we take the line of sight out of it. So yeah, in that application, absolutely, that's a way to go. Because you've already invested the money into the radio connectivity. So now we're just letting programming take over. So yeah, that's a good place to use. So, but that's like I said, if there's any more questions, we got a few minutes left. I was just finishing up about the website with the password protected, and we'll have a bunch of new stuff on there. I know in the beginning I mentioned that there for the people that tuned in, I'm gonna try to get some IMSA points for these. For those that watch the video, you'll get the points. I don't know what the points are worth. They're 2-hour videos, so I don't know if you get a point or two for each one. But I'm gonna try to get you guys, and what I'll do is I'll just email you. I'll email you all your certificates, so you'll get credit, and then you can apply them. I'll try to come up with a link. Because you have to go apply those points to your own membership numbers so you get credit. That's on you, not on me. So I'll try to send out some information on that. Give me a little bit of time. If I gotta do all the certifications, it might take a little bit. So IMSA doesn't work quick with that, so I'm not working quick with that either, but I will get them to you. All right. Like I said, that's about all that I have. If anybody else has any questions, again, I really appreciate everybody tuning in. Be on the lookout for the TS1, TS2 videos. That quick one hitter is like 15 minutes. Very informative, I think, something you can go back to. And then, any ideas you want for new classes, send me in. I have an idea for next week. Really nothing beyond that. We'll see what happens in regards to all the states opening up. Obviously, if the state's opening up, then on Tuesday afternoon at 10 o'clock, I'm going to be out on the road somewhere. So it's not to say I won't do these. I may slide them to Friday or something. It was a good time because nobody had a lot going on. But that's all I have. I don't see any more questions.
That's about it.
Yeah, that's about it. But again, I appreciate everybody tuning in. I do these for you guys. The reception was great. It makes me want to do more of them. We're doing something right. It's all about learning. I want to create the lines of dialogue. If you don't want to ask the question here, or you didn't fully understand, follow up, you know how to get a hold of me, email, text, give me a call. For those people that log in and call me on Tuesday morning with problems, I apologize. I'm generally getting ready for this class. I had a couple of calls this morning I couldn't field because I'm getting ready for this. So Tuesday morning. All right, that's all I have. You guys have a great day, great rest of the week. Be safe, and we'll see you next week. Take care. Bye.